All right, so you can see, I don't know if you're able to read that, but you should be able to see the numbers underneath there. They kind of got washed out. So we're gonna add some salicylic, some iron chloride to each one of those to see if it turns purple. So I'm gonna add it first to the crude because I want to see what happens with the crude. And I only need a couple drops. It's crude aspirin. That's the aspirin before we purify. You see how purple it is? That's full of crap. That's what you don't want. So now we know what we don't want to see. So I'm going to add this same iron chloride. I'm going to add a drop to pure salicylic acid to see what happens there. Hopefully you can still see that. So we're going to add one drop, 1 or 2 drops to just pure salicylic acid. You can see right away how dark it is. All right. And that's what you expect. Because in the video, it said that the iron chloride forms like a complex with salicylic acid and it turns purple. So you can see that. Can y'all see that? So the plain pure salicylic acid also turned deep purple. What you don't want is for your aspirin sample to look that color. You want it to be lighter than that. The lighter it is, the less salicylic acid is left over after you purified it. So let's see what this is sample 11. You can see immediately that first sample 11 on the end, can y'all see that? Right, it didn't turn purple at all. It turned like a very faint purple, which is good. That means it's very pure. If it was dark purple like the other two, that would be bad. That would mean that it's crappy and you have to purify it again. All right, I'm gonna do 30. 30 got a little more purple in it. Can y'all see that? You see 30 on the left, second row on the left, compared to the last well at the top right. 30 is a little bit darker than 11. So that means that it's a little bit less pure, but it's still not bad because it's faint. The purple is still faint. So that's good. All right. It's darker than the other ones. Can y'all see that? See the difference? Mm-hmm. How 11 is like really like faint, and then 30 is a little darker, and then 106 is very dark compared to both of those. Can y'all see that? So this is 106 here, and this is 30, and this is 11. You can see 11 out of those 3 samples. 11 is the purest out of all of them. All right. Any questions about the purple color test part? The color code for the pH. All right, so we're gonna use that. We're gonna dissolve these samples up in ethanol, just like we did the last ones, and then we're gonna use this guide to kind of help us determine what the pH is. If it's the darker red it is, the more acidic. As it turns from red to green, neutral, and green to blue is basic. But you don't expect it to be basic, right? Because there's a free carboxylic acid in that aspirin molecule. So you expect it to be somewhat acidic. So let's find out, just like that. And they're just going to dip it into where their sample is and read it. Mm-hmm. And you want to read it immediately. You don't want it to sit because this paper is air sensitive, water sensitive. So it might start out red. You come back in 10 minutes, it's blue. Mm-hmm. So you want to read it right away. And then just record on your paper what your pH is, and then whatever you got for 11, that's what we're gonna put in the chat. Mm-hmm. What you get for 30, we'll put that in the chat. For 106, we'll put that in the chat. Y'all, we can work with off those values.
So did the whole thing in?
Mm-hmm. Just the tip, just the edge of it.
Orange?
Mm-hmm. Didn't change much, did it? Mm-hmm. So where are we? So it's orange. It's kind of right there about 4. Let me see. Let me show them so they'll know. So this is the pH meter or the pH guide, and this is the strip after she dipped it. So it looks like it's close to about 4, which is expected. Somewhere between 3 and 4. You expect that. Because again, on aspirin, you got this free carboxylic acid that is acidic. I mean, those proton is transferable. So go ahead, Brooke. About the same, huh? Mm-hmm. About 3 or 4. Same for that one. And again, this is the guide right here, so we can match it up. And let's see. Yeah, about the same. So we're looking at each one of the samples having a pH ranging from 3 to 4. So it doesn't matter which one you pick, 30, 11, 106, doesn't matter. They all have a pH of about 3 to 4. Do the melting point with is this instrument right here. It's called a melt temp, right? And so the way we use the melt temp is very simple. First, we got to plug it up, obviously, because it's electric. And then after that, what we want to do, the way you measure the melting point, if you watch that melting point video, hopefully you did, you ramp the temperature up until you get about 20 degrees away from your melting point. Who looked up the melting point for aspirin? That's Fahrenheit. So about 135 Celsius, right? Okay, so we're expecting 135. So we're going to ramp up the melt temp using this little dial right here. It's very rudimentary. We're going to turn that dial to about 4, somewhere about 4 or 5. Don't do it yet because you don't have your sample in there. And then when the temperature gets to about 115, we're going to turn it down to about 3.5. And that way it'll slow down the temperature increase. Because once you get to about 20 degrees out, you want to increase the temperature about 2 degrees per minute. This is very tedious and time consuming. So we got 3 melting point capillaries, and we're going to put some sample into these. I'm going to take one of them and put some crude in it for each one of you. So you're going to measure your pure stuff against the crude. You expect the crude, you see that the crude, how dark purple it turns crap. So it's not going to melt at 135. It should melt way before that because it's full of crap. The more pure it is, the closer it's going to be to that 135 expected temperature that you looked up. All right. So we're going to take some sample and I'm going to show you this. Normally, you have a tube that you can drop your melting point capillary down in to get the aspirin to settle. What you don't want to do is jam it into the aspirin because if it gets stuffed, it's not going to go down. So let me show you what to do first, and then you can take it from there. Man, this thing needs to turn down more. All right, so that's my crude aspirin. I'm going to take my capillary, and I'm just going to dip it in here on the open end now, not the closed end. I'm just going to dip it in, and you can see I got aspirin in the tip. Can y'all see that at home for your viewing pleasure? Just tap it on the bench top, just like that. And you just keep tapping it until you can see a little bit of the aspirin has gone down, but not all of it. So you just keep tapping until you get it to the bottom. You want to have it about 1 centimeter, maybe a half a centimeter from the bottom. That way, when you put it into the melt temp, you can actually see it. That's the purpose for the amount. Right, so y'all see how that got to the bottom just by a little finesse and a little tapping. That's what we're gonna do. So I'm gonna put a little bit more in here because that's not quite enough. And again, you don't want to jam it because if you do, then it's gonna get stuck at the top and it won't move. That little circle that can y'all see that inside of that? Yeah. Just like you see those little grooves in there in the melt temp. So you kind of ramp the temperature up and you look through that viewfinder to see if your sample is melted. It's very important when you're doing a melting point to write down the initial temperature when your sample starts to melt. Right? So if it starts melting at 120 and it stops at 128, that's what you record as your melting point. Right? Because it's really a range and not really a point. So there's a range of temperatures that your aspirin is going to melt over and not just a single point. Can y'all see that sample, that tube that's in there? Can you lift up on it a little bit just to see if we can see it, if I can see it moving in the camera? Yeah, there you go. Can y'all see that?
Yeah.
Okay, that's one sample. So we're going to load the other 2 samples in. And then we're going to ramp that temperature up. And when it starts melting, we're going to ramp the temperature down and slow the heating down so we can get a good, accurate melting point, right? So this is like watching paint dry. But I'm going to try to get another shot of all 3. If y'all can see that, she has all 3 of her samples loaded. So you can see right here, that was a solid, and now it's kind of, let me see, and now it's fully liquefied. So that's what you're looking for through that viewfinder. And the crude for 11 was started at 110 and ended at 115. So that's about 20 degrees off the expected melting point for aspirin. Let me see if I can let y'all see this. I don't know if I'll be able to see that, but everything in there should be, come on, camera, liquefied. Can y'all see that?